So this is a great question to test your understanding of forces and how they add together. We have an object of mass 2 kilograms being pulled by a force and accelerating at that rate shown there, 2 meters per second squared. And we're asked what the coefficient of dynamic friction between the object and the surface is. Now, in any kind of situation like this, it's always worth to work with what you've got. You're told that the object has a mass of 2 kilograms and acceleration of 2 meters per second squared. And so therefore, what we can do is we can calculate the resultant force using F equal ma. Now that will be F equal to 2.2 times 2, which is 4 newtons. What this is saying is that there is a resultant force to the right, which has got a magnitude of 4 newtons. Now, why is that important? We've got a force which is pulling the object at 12 newtons, which must mean there's other forces in there. And of course, friction is going to be one of those. We have friction pulling back. We also have a normal force, and we also have weight. These are the 4 forces acting on the object at any time. Let's do the rest of the analysis then. Well, we can see that if the applied force is 12 and the resultant force is 4, there must be a force of 8 newtons, which is acting in the opposite direction to the motion, and that's the friction force. We also know that friction is given by mu, the coefficient of dynamic friction in this case, times n, the normal force. And because the motion is balanced in the y direction, the normal force must be equal to mg, the weight of the object. It then remains for us to say, well, mu is therefore the force of friction divided by mg, which is the normal force in this case, which is 8 divided by 2 times our 10. 8 over 20 is going to give me a dynamic coefficient of friction of 0.4.